Right, so I wasn't going to make a video about this one because I thought it was going to be quite a boring fix, but it turned into an interesting fix halfway through, so I thought I'd just record the process of diagnosing this particular fault. Now, of course, this is a Technics turntable, which needs no introduction whatsoever, and the problem it's having is the platter is not maintaining a consistent speed. It's oscillating at quite a high frequency, sort of speeding up and slowing down very, very fast. That can mean any one of a number of things. Normally it's the pitch fader. It's just either gotten dirty or it's otherwise broken, but I've checked it and it's absolutely fine. It can also be the motor drive chip, can sometimes burn out, but that's a bit of a pain in the arse to check. So I'm going to check the other two things first, which are the motor drive coils and the position sense coils. These coils are very fragile, especially the position sense coils, so I'm betting it's going to be one of those. These coils don't normally break in everyday use, but I know this turntable has been apart recently because the owner customized it somewhat with a rather fetching green spray job, so he could have easily accidentally damaged one of the coils. Now, luckily the coils are easy enough to test. You just need to measure the resistance across each one. If the resistance is near zero, it means there's a short in the coils, and if the resistance is infinite, then you've got a break in the coil. Now, you can turn the circuit board over and measure the coils directly on the circuit board, but I'm lazy and I don't like having to remove any more screws than necessary. So what I normally do is I measure the resistance of the coils just against the pins of the turntable drive chip. That's the chip marked IC101. To measure the position coils, you want to stick one probe on pin 17 and the other probe on pins 11, 13 and 15 in turn. They should all measure about 10 ohms each. You'll also have to check the other position coil winding between pins 18 and 20. To measure the drive coils, you want to put one probe on the furthest away leg of the component marked R101, that's a 10k resistor, and pins 1, 2 and 24 in turn. They should all measure about 30 ohms each. Now, in this case, I'm getting an infinite resistance between pins 17 and 11, so it must be position coil P3 that's burnt out. Now, the coils are marked underneath the circuit board, so it's fairly easy to locate them. Now, you can actually buy the whole stator assembly, as it's called, for about 20 quid, but as it's only one coil gone out, it seems a bit of a waste to just throw out the whole thing, so I'm going to pinch the coil from another partially broken stator assembly I've got lying around the workshop. First, we need to desolder the old assembly from the circuit board so that we can get into the ends of the coils, which are underneath it. Then we need to pull a coil off the donor stator. The coils aren't glued in very well. You can just often pull them off or pull them off with a pair of pliers, so it's easy enough to remove them, and then you just desolder them from the PCB pins on the underside of the stator. Then you just basically do the same thing in reverse on the stator we want to fix, and yeah, that's basically it. It's a good idea to secure the coils with just a tiny, tiny bit of super glue. And super glue is kind of the opposite of flux in that no amount is too small. Really, it's easy to overdo super glue when you use it. So I'm just going to use a tiny, tiny drop. It doesn't need to hold it in with any particular force. It just needs to stop it rattling about when the turntable's being moved. So yeah, now we just need to solder the stator assembly back in, put the screws back in the clips, and yeah, give it a test, and everything works fine.